This conference will now be recorded.
All right. My name is Stephen Ross. I'm president of CarmelSoft, and we are a mobile and web-based software development firm for the HVAC industry and also for the built environment in general. And we do a lot of consulting for HVAC OEMs like Courier, Mitsubishi Electric, Trane. Also, we've developed some web tools for ASHRAE. And we're also currently working with a couple other HVAC organizations. So today I will be demoing our HVAC ResLoad-J app. This is a mobile application, works only on the Apple iPad, and it performs manual J8 load calcs for residential and light commercial buildings. It is approved by ACCA, has been approved for actually a decade now, since 2012. It's our 10-year anniversary of this app. We have thousands of users throughout the world using this application to perform peak cooling and heating loads for homes and light commercial buildings. So today I'm going to demo this app and show you how it works, and also show you a couple new features we've added over the past 6 months. So as I mentioned, feel free at any time to ask me a question, or if you want to see something or want something in more detail, obviously unmute yourself, ask the question, then remute yourself so we don't hear background noise. All right, so what you see here on your screen is what's called an emulator, and this is actually running on my MacBook, and it looks exactly like what you would see on your iPad. So it's great for training sessions like this. It's also great for debugging the software and developing it. So I'll be showing you this, or training you in the landscape mode of this app. There's also the portrait mode that you can see. So if I rotate it, you can use the app in portrait, but you'll see that in landscape, it's a little nicer because you get to see the list of projects and envelopes and windows, etc., on the left at all times. So I think most people actually use it in landscape mode. So that's how I will be training you today in this mode here. All right, so what you see on the left here are projects. And a project is basically a home or a building. And you can select existing projects. And then on the right, you can see the various inputs and parameters for that project. If you want to add a new project, you click the plus button here, and it will pop up a form. And it will allow you to type in a name and click add a new project. Now, a really nice feature that a lot of people use is the feature to copy existing projects. So if you have an existing home, and suppose you service a bunch of homes which are fairly similar, you can actually copy from an existing home into this new home and then edit the data for this new home. So in other words, you don't have to re-enter your data all the time. In addition, you can create templates. So if you want to just always have a base template available to you with some base inputs, you can always copy from that input. So it's a really nice feature, saves you a lot of time in re-entering data. For the sake of time today, though, I'm not going to create a new project. I'm going to work with an existing project. All right, so on the right here are all the inputs associated with the project. And also a common theme throughout this app is you can always swipe. So you can see the little dots at the bottom here. That means there's other screens. So if you swipe from right to left, just like this, you can see there's additional inputs. A lot of people miss that. People always ask me, hey, where do I enter the cooling set point or the heating set point for my home? I can't find an input. Well, just when in doubt, swipe. And there's probably another screen available with inputs. Now, there's actually two main modes in this app. And you'll see up top here, it's the block load and the room by room. So the block load mode is you look at the home or the building as one big block. You don't care so much about what's inside it, okay? You think of it as one big block. And that's kind of how you size your equipment, right? How you size your cooling equipment and your heating equipment based on that block load. However, if you want to get more granular and you want to start sizing for rooms within your home and also airflow, so you can size ductwork, Then you do your room by room. So you always start with your block load, no matter what, because in your block load, you define all your constructions. And then after you do your block load, if you want to get more granular, you go to the room by room mode, add your rooms, and then you start assigning those constructions that you created in your block load to the various room, envelope, window, and skylight elements. And I'll show you all this in a bit. So you don't have to do a room by room. If you just want to size your equipment, all you need to do is your block load. And that's what's nice about this app, because face it, you're going to use this app out in the field. You don't want to spend 2 hours doing a load calc. So the nice thing is you can do your block load in a relatively short period of time. Most people do it, and depending on the size of the home, could be 15 minutes, could be a half hour, maybe 45 minutes if it's a large home. And then, if you don't want to do room by room, you don't have to. However, if you do want to get more granular, you can do room by room, and of course that'll take a bit longer. So this app is really geared toward you using it out in the field, not having to write down the information, come back to your office and enter it into your desktop app. This is a field-based app. All right, so let's start with the block load mode. So I've selected my home here. On the right are my parameters. As I mentioned before, you can swipe to see additional ones. So I'm not going to go through every single input because it would take us literally 3-4 hours to go through it all. We only have an hour today. So I'm just going to touch upon some of the main inputs, main parameters. And of course, like I said, if you do have any specific questions, feel free to ask me and I can go into more depth. So in this section, you just enter your demographic information. The most important thing here is your city. You see this little caret icon here. You click that and up pops your climate or your weather data form. So what you would do is you would select the state that you're in and the city that's closest to where you're located, and it will populate ASHRAE and ACCA weather data. And all this data either comes from the ASHRAE weather database or the ACCA Manual J8 handbook. And then you can also override. So if you say you're in Fayetteville, Arkansas, and you think, hey, 93 is a little cool, let's enter 95. You can go in there and change it to 95, excuse me. And it will update it for this specific project only. The next time you have a project in Fayetteville, it will go back to 93, but you can always override it again. You can also do a map feature. I'm not sure if this works on my emulator so well. Let's see if it does. Oh, yeah, actually it does, yeah. So, so the map feature is nice because it kind of shows you push pins of where all the weather data is. So if you say you live in Rogers, you can kind of see, hey, this push pin's close to Rogers, so let's select Fayetteville. So it's a nice little feature to show you, which push pin you should use or which city in our weather database you should use for weather data for your town that may not be listed in the weather database. All right. So once we've done that, it will automatically fill in my city and state. You can override the city name if you want, but it will still maintain that weather data that you selected. All right, so down here, let's talk about the total floor area and these types of inputs here. So you can see that, I can always, in this case, my mouse, but obviously when you're using your iPad, you use either your stylus or your finger. And actually, let me display my keyboard here. Bear with me for a second. There we go. All right, so when you put your finger in this input or your stylus, it will pop up the keyboard and you can type in a value. So, I could type in, say, 2,500. Okay. Another way to update this input is using this slider control. And as you can see, as I move the slider, it also updates the value. So you also notice that the slider below it is moving in tandem. Because if you see here, most of the time you're going to heat the same area that you're going to cool. So in this case, we're going to have the same values for both. And you can tell that because this value is maroon. So any value that you see as maroon means that it's derived or calculated. Okay? So in this case, it's derived. However, you can always override this. Suppose you heat maybe less area than you do, you cool in this house. So let's say 2,500 square feet. Click done. And you can see now that I've overridden it. It's now a black value. So it's no longer derived, and then you can see it no longer moves in tandem. If you go back and just delete this value and click enter and click done, it'll go back to being in tandem. So like I said, it's a common theme throughout this app. Anytime you see a maroon value, it means that it's either calculated or derived. And also, many of the inputs do have slider controls like this. And the nice thing about these slider controls is it kind of helps you see dynamically how it affects your load. So here, why don't I address this little portion here? This is the pie chart and a breakdown of your cooling load. And as you can see, as I move my slider control for my total area, it's updating my cooling load. Now, what's it affecting? Well, it's affecting my duct and blower heat gain, as you can see. And that's how it's affecting my load. Also, if I select cool heating, same thing, duct heat loss. And then I'll explain the AED curve in a bit. So this is a nice feature because it gives you instant feedback of what your load is, your breakdown, your total load, and your airflow. All right. I'll address a couple more inputs here, then we'll move on. So you have your total floor area. You're going to enter your average room height throughout the house. So the real goal here is you multiply the floor area times your average room height, and you're getting your total volume. Okay. It's important to get the volume of your home for the purposes of calculating infiltration and also ventilation. Okay. So the real goal is to get your volume. So, you can either look at the footprint of your home or the total area of your home. Depending on whether you do that, you either select the average room height, each room, or if you do the footprint of your home, you would do the total height of the home. So it's really the goal here is to get the volume of the house. Down here, you enter the number of bedrooms. And then as you can see, this is a derived value. So always the number of occupants is 1 plus the number of bedrooms according to ACCA. So as I, move my slider, you can see it increases my occupants. And like before, you can always override that. All right, let's talk about appliances loads. So you can either do default, low 1200 BTU per hour appliances, meaning TVs, computers, dishwashers, medium 2400, high 3400. Now, the real powerful one is custom. So if I click my little caret icon, I can now create a whole custom list of appliances, and it will add up all of my sensible and latent loads and give me a total internal load. So if I click my plus button here, and click the little caret, you can see there's a whole list of appliances here. We're talking all the way from coffee makers, toasters, dishwashers, color TVs, computer monitors, etc. So let me select computer. And suppose, these days people will have multiple computers in their home. Let's say I have 4. And then what it's going to do, it's going to multiply 4 times 1500 BTU per hour for a computer, but my average use of that computer is only 35%. It's not like that computer's on all the time. So here's where you enter the percentage of time it's actually on. And this is my total BTU per hour, sensible total BTU per hour contribution due to my 4 computers, assuming they're on around 35%. So about 2000 BTU per hour, which sounds pretty reasonable. I mean, truthfully, this data comes from the ACCA Manual J8 handbook, which is based on 10-year-old data. Obviously, technology has changed tremendously in the past 10 years. So some of this data may be a bit high, a bit off. But overall, it's pretty, a pretty good approximation. All right, let's look at the color television. A lot of people have multiple TVs, so let's add 3 here. Once again, average 683 BTU per hour. Heat, sensible heat, 100% on. Well, these days it seems like TVs are on 100%, but let's assume 50% of the time it's on. And then here's my total load to my 3 TVs, 1000 BTU per hour. And you can keep doing this. You can add dishwashers. You can have dryers, washing machines, etc. So you can create a whole list of appliances, and once you're done, what it will do is add them all up, and here's your total internal appliance list, BTU per hour, including sensible and latent, and it will fill it in here under your internal gain. So these numbers are a bit different, and I'll explain that in a bit. But this helps contribute to your internal gain. Because internal gain not only includes your appliance list, but also includes the number of people too. So that's why this number is a little higher. All right. Before I move on to the next screen, are there any questions? And if you do have one, please unmute and ask away. All right. I'll take that as no questions. I'm going to move on to the next screen. So as I mentioned before, you can always swipe from right to left when in doubt, and you're going to see a whole new slew of inputs. Once again, I'm not going to go through everything here just for the sake of time. But the important ones are obviously, you want to set your cooling set point and heating set point. You can use your slider, and this is pretty cool because as you move your slider, you can really see how it affects your load. As if I want a really cold set point for my cooling, you can see, I'm at 34,000 BTU per hour for cooling, and then if I go up, say, to 75, I go down to 30,000. Not a huge difference, but in some cases, your set point really can make a difference in your load. So why don't I set it to 72? And then once again, heating, same thing. So if I click heating, and then I move this slider, you can see how my heating load is changing. If I go down to 68, or if I want it nice and toasty, go up to 78. So you can see how it really affects my load there. All right, indoor relative humidity, most of the time it's going to be 50%, so you just want to leave it at that. Cooling supply air temperature, so this is the temperature of the air coming off the coil. Most of the time it's 55. Now, a lot of times, we get probably most of our support calls are always asking, why is this airflow, this is not the airflow that I would think would be, correspond to my total heating. Well, if you think about it, airflow is calculated, total cooling here. So airflow is really calculated from your total cooling divided by your delta temperature, meaning your set point minus your supply air temp, times a factor, 1.1. And that value applies to sea level. Once you get up to Denver, 5,000 feet above sea level, that 1.1 becomes quite different. So if you want to change, if your airflow you're seeing here just doesn't look right, if you want to change it a bit, try messing a little bit with your cooling supply air temp. So let me change this down to 50. Let's see how it affects my airflow. So now it's down to 1,300. Not a huge difference, but it will make a difference. So you can always tweak this supply air temperature, especially if you need to present these reports to the city or to whoever. You can always tweak it to change, the airflow a bit to make it more in accordance to what, say, your equipment tables, your HVAC equipment tables are showing. So that's a nice little trick you can do there. All right, construction tightness. This kind of lets you specify, how well is this building built? Is it a newer building? Usually most newer homes, newer commercial buildings have tight construction. You're not going to have much leakage in the windows or under the doors. Older homes, more average, and obviously really old homes that have not been retrofitted in 50 years are loose. And what this does is this will affect your infiltration load, okay? Because obviously the more loose construction, you're gonna have more air seeping in from the outside, especially in the winter. When in doubt, just select average. All right, so I've selected my tightness. Now I'm gonna select my cooling infiltration method. If I select that, up pops a form, and there's 3 different methods from which I can determine my infiltration. There's the Manual J air change, blower door, and direct entry. I'm going to explain this one in the direct entry. Blower door is much more complicated. I don't want to go into it right now because that could take an hour in itself. Let's talk about the Manual J air change method. So basically what it does is it asks you here, what are the exposures of your building? Because it's, it's trying to figure out, where's the wind going to come into this building? So there's a 3 or 4 exposure, single, 2-story, or a townhouse. And based upon that, and also based upon the construction tightness that you just selected, it will automatically calculate the number of air changes of infiltration and the CFM of infiltration air. Then it will take that and calculate your infiltration load, which is here, which is pretty modest, 865 BTU per hour. Now, I can also brute force and just enter an airflow. It's like direct entry method. I could just go say, hey, I know it's about 0.1 air changes per hour, which is the equivalent of 27 CFM. And interesting. I wonder why did it go down to 0? I think it went down to 0 because this is one thing I do want to explain is even though you may enter an infiltration method, it could still be 0 because what's happening is your ventilation is creating a positive pressure in your home and it's pushing out any possible infiltration. So that means your infiltration will be 0. So the ventilation and infiltration calculations are all calculated in coordination with one another. Because if you do have a positive pressure, you're not going to have infiltration. If I go back to the other method where there's more CFM, that means now there's not as much of a positive pressure, so we're going to get some infiltration in there. So that's why we were seeing 0 before when we had a lower infiltration CFM, because the ventilation was so much greater. All right, next thing is heating infiltration. Same thing, 3 different methods, number of exposures. The only addition is the fireplace, because you could get infiltration through your fireplace in the winter because of so much wind. So you enter the number of fireplaces here, then you enter the construction tightness of that specific those fireplaces. When in doubt, just use average. And then when I click done, go into heating here, you can see that my infiltration here actually in the winter is almost a half a ton, or 6,000 BTU per hour of heating. So pretty significant here. All right. Any questions before I move on to duct? Get lots of questions about duct. All right. So just remember, this is not a duct design software tool. This is not a Manual D. This is Manual J. We get lots of questions about Manual D. We're currently developing a Manual D tool, which is obviously where you design a whole duct system, residential duct system, using using like a drawing program. However, it's totally separate from this. What this section does is just allows you kind of to define an overall system, so we can calculate both the heating loss and cooling loss. Because if you have a really leaky duct system that is not very well insulated, it can add a significant amount of load, literally tons of cooling load, if it's a big system that's not insulated, that is leaky. And I'm going to show you an example of that. All right, so you can add as many systems as, or actually, you can add up to 5 systems in your home, which is pretty much enough. Most people just add 1. And then I'm going to define my supply system. And here's a bunch of parameters here. So these parameters will change depending upon your duct location. So you may have duct in your unvented attic, or your open crawl space, or closed crawl space, or unconditioned basement, or maybe you riser or drop an exterior wall. So let's assume it's a riser or drop an exterior wall. And then my supply duct system, that's the only option there. Duct configuration, single, 2-story. Let's do 2-story. What's the duct R value of the wrap or insulation? Let's say it's R4. Now the big input here is duct leakage. So we could say it's a really low leakage, sealed and tested, pretty much brand new ductwork, or is it really unsealed, leaky? And I'm going to show you the difference between sealed versus unsealed. So you can see now kind of in the back here, my duct heat loss, actually that's heating. Why do I do this? I'm going to reselect this, go back, click done. All right, so you can see my duct loss is about 2,600. I'm going to go back in here, and I'm going to change this to an unsealed, really leaky duct system. Let's see how it changes it from 2,600. Didn't change it. Why is that? Let's go back and see. I must have selected. Not sure why it did not change that. Should have. So let me do this. Let me select the unvented attic. 25 unsealed. Go back and see what happens. Okay, there we go. Now you can see it's over a ton now. If I go back and select sealed and tested, goes down half of that. So really, when you select, duct leakage, it really can affect your duct, heat loss pretty tremendously. In this case, almost, 3/4 of a ton. So it's important to get these right. Now, probably the main input here is your actual duct surface area. So what the program does is it will automatically calculate the duct surface area based on your total floor area times 18%. And that's a value that was provided by the ACCA Manual J8 handbook. And as you can see here, it's a maroon value. That means it's derived. However, if you know for sure what the total duct surface area is, you can manually enter that just here, and you can override it. But in this case, it was 455 square feet of duct surface area. If I go back, click done, and you can see here, here's my duct heat gain of 7,600, and also includes blower heat gain, which is minimal. And you can do the same thing for return if you happen to have return. If you don't have a return system, just enter a value of 1 and it basically negates it. But if you do have a return duct system, you would select all the parameters that are appropriate to it. All right, any questions about the duct inputs?
Yes, I have one.
Sure.
Some of my ducts, my unit is in the attic. There's one particular job I'm getting ready to do a load on, or I'm working on it. Some of my ducts and my equipment are in the attic, but it goes down through the center of the house to a conditioned crawl space. It's all insulated and well sealed. So what do I do about that?
Yeah, you may want to divide that into 2 systems. Because as you can see here, you can actually click plus and create a new system. So you may want to do half that duct system in one system, which would be, I think you mentioned in your attic, and the other half or other portion of it, as the riser in the exterior wall. And then you would enter the surface area for that. So you may want to break that down and see what happens.
It goes down in the middle of the house, so where it goes down, it's all conditioned space around it. And then also the crawl space is conditioned. I don't see that you have a option for a conditioned crawl space.
Oh, let's see here. So unvented attic, closed crawl space below insulated floor, no wall insulation. Yeah, I mean, these were the options provided by the ACCA Manual J8 handbook. And I guess what I would do here is if it's all conditioned,
just forget about it.
Yeah, you can almost ignore it because there's really going to be no heat loss across.
That's what I was thinking of doing, because all the walls are insulated. The crawl space is sealed. It's about 3 feet tall. We got 2 4x10 registers down there. So I was thinking about forgetting about that duct, not even calling it anything.
Yeah, I would say you could just ignore it.
Okay. All right.
Yeah, because I think that'd be the best thing.
Thank you.
Yep. All right. Any other questions before I move on? There's still a lot to cover. All right. So let's move on. If I swipe again, you'll see here, this is a common theme throughout the app where you can see a much more detailed breakdown of your cooling and heating loads. And it shows you not only the values, but also the percentages. And this type screen is throughout the app. All right, so we've entered all our project inputs. Let's move on to our envelope. So within our block load mode, which we're in, you click the envelope, sub button here, and now you can start adding all of the envelopes. So envelopes are defined as above grade walls, wood metal doors, basement walls, partition walls, ceiling, partition ceiling, and floors. And like what we did for our project list, you can always add new envelopes by clicking the plus icon. You can copy from existing. So once again, if you have a template that you want to copy over and over again to save time, save you from having to re-enter data over and over again, you can do that. Once again, for the sake of time, I'm going to just select existing. I'm going to select existing envelopes and show you the parameters that are involved. All right, so I've selected an existing wall. This is a west wall, and the type is above grade wall, this meaning this is an outdoor, a wall that's facing the outdoors. So one thing that you can, one thing that's good to remember, and we get a lot of calls about this, is, people are asking, do I need to model the interior walls that are, separate my living room from a dining room? And, similar to what I think Bobby just mentioned, in terms of his duct runs, his duct work is running in conditioned space. So there's really no need to model it because there's no heat loss across. Same thing with interior walls. You don't really need to model interior walls that are between 2 conditioned spaces. You can ignore those. The only time you would model an interior wall is if on one side of that wall, say it was the garage or an unconditioned space, then you would model it, and you would model it as a partition, which I'll show you in a bit. So just one thing to remember, it makes it a lot easier that you don't have to model all the interior walls in the home, because that would take a tremendous amount of time, and there's absolutely no need to do it. All right, so we've selected our above grade wall. We select our orientation here, and this is not so much important for the wall load, it's more important for the window load, which I'll show you in a bit, because what we do is we attach our windows to our walls. And by doing that, we then tell the program, oh, our window is facing east, and it will do the calculations for an east-facing window. Our construction number. So I select this, and you'll see it pops up a form, and this literally has hundreds of construction types. These all come from the ACCA Manual J8 handbook for our walls. So you have category of frame wall, block wall, and alternative. So under frame wall, I can select from my list here. And as I select from the list, it displays the details below it. And then I click done. And what it does is automatically fills in my U value here. U value is 1 over the R value. Now you can see this is a maroon value, meaning that is derived from the construction number that I just selected. Of course, you can always override this if you happen to know the exact U value of that wall. Also, the CLTD group, this is more of a solar type factor that's auto-filled in according to the construction number you select. These group numbers are all defined in the ACCA Manual J8 handbook. If in doubt, just leave this number alone because it is automatically selected according to the construction number. Down here, we enter our wall width and height. And as you can see, as I move my slider, it changes my cooling load on the right here. And as you can see, it's affecting my envelope load. All right, and then you'll see some numbers down here. These are values that apply directly to this wall itself. So in other words, this wall is contributing 3,100 BTU per hour of cooling and 6,300 BTU per hour of heating. So just a nice little checksum for you to see how much load is this wall contributing to my total cooling and heating load. All right, so as I go down my list here, you see I define my south wall. Actually, I need to select south here. East wall, let me select east. So let me make sure, is this west? Oh, let me select west here, make that a west wall. All right, and then north wall. All right, so now we have all our exterior walls. Now let's talk about a ceiling. So in this case, we have a vented attic, and I'm going to select a ceiling, and then the ceiling, we'll select if it's sloped, we want to select the orientation that is facing. And once again, the main reason we want to do that is if we have a skylight, we're going to assign that skylight to our roof, and it will of course affect the load depending upon what direction that skylight is facing. And then under construction number, here's a whole another list of categories for roofs. Under attic, roof deck, and roof joist. So under attic, I have a whole list here. As I move through the list, it displays the details below. Click done. It will auto fill in my U value. Here, I can override it if I want. Then here I select my ceiling length and width, and then the slope of that ceiling or that roof, if there is one. All right. And then briefly, I talked about partition wall. So this is an interior wall that is adjacent to an unconditioned space. So I select the partition wall panel here. The construction numbers, these are actually the same construction types that were under my above grade walls. Auto fills in my U value. CLTD really is irrelevant because there's no solar load in interior walls, but we left it in here. Here's my wall width and wall height. Most important down here, though, is I need to enter the temperature on the other side of that wall. So, for example, if you have a garage that is not conditioned, in the summer, suppose it doesn't have insulation, it gets really hot, 95 degrees, probably a bit too high. Let's enter 80 or 85. And then in the winter, it gets quite cool, down to 45. So these are the delta T's these are the values that are included in the delta T calculation. Here's your total load due to that partition wall. And then also you can define floors. So floors really only transmit heating, not so much cooling. So it's more heat loss in the winter because of the surrounding ground. So here you can define your floor, and here's a whole 4 different construction categories for all different types of floors. And then you fill in, the parameters will change depending upon the floor that you select. In this case, it only cares about the length of the exposed edge of that floor, and also is this floor radiant or not. And you can add as many envelopes as you want. And then once again, if you swipe from right to left, you can see this breakdown, which I showed you in the other, under the project tab. All right, so we've defined all our envelopes. Let's go to window. Any questions before I start talking about the windows? Okay, so windows, same thing. You have your whole list of windows on the left. You can add new windows by clicking the plus button. You can copy from existing windows. Once again, if you have a template that you want to copy over and over again to really save you time, you can do that. Real nice feature. So here I've defined a whole bunch of windows. And the thing about windows is you're always going to attach your window to a wall that you defined under your envelope section. The reason is, as I explained before, is it's really important for the software to know what direction that window is facing. Because a window that is south or west or east facing, mainly south facing, is going to have a lot higher cooling load than a window that is north facing, at least in the northern hemisphere. Southern hemisphere is the opposite. So here, attached to wall, it will display a list of all of the walls I defined under my envelope section. So in this case, I am going to attach it to my west wall. Also, the nice thing is it will subtract out the area of the window from that wall when it calculates that wall load. So it makes it a bit more accurate. Construction number for this window, basically different types of single, double, or triple pane windows. And depending upon the construction number and also the frame construction that I select, it will auto-calculate my U value of that window and my solar heat gain coefficient, or SHGC value of that window. Once again, as you can see, these are maroon, so you can always override those. So if you're installing new windows and they have that nice big label on it, which actually shows you what the R value and the SHGC value are for your Anderson or Milgard or whatever windows, you can enter that here. Window type, default, bay, garden. Unsure, just enter default. Then here you would suppose, a lot of times you may have 5 windows on a wall that are all the exact same size. Well, in this case, what you're going to do here is you're going to enter the area of one of those windows and enter the quantity of, say, 5. And all it does is it multiplies this number by this number. That's all it does. So if you have, 5 different windows, all different sizes, just add up all the areas of those windows, enter that total area here, and just enter a value of 1 here. All right, the unique thing about windows, though, is you have lots of, you could have lots of shading, and it really does affect your solar heat gain. So you can have internal shading. So if you select this, it brings up a form that allows you to select between blinds, roller shades, and drapes. And then you can select what percentage of that window is covered by that internal shading. In this case, it's 100%. Do you have an insect screen, either non-internal insect or external insect screen? And once again, what percentage of the window does that insect screen cover? Down here, we can select whether we have a sunscreen. Different options. No sunscreen, 1, all the way to dark sunscreen. And then once again, you can enter the percentage of the window that sunscreen covers. Here on the bottom right, you can select exterior shading. So what's your ground reflectance? What is your home surrounded by? Is it surrounded by grass? It's not going to reflect as much sun as it's surrounded by new concrete. So you can also enter parameters for an overhang, because obviously an overhang will provide shading to your window. So in this case, you enter the height of your window, the overhang length, and the distance that the window is below that overhang. And based on these parameters, it calculates all the geometric values, and it will calculate what percentage of that window is actually shaded by that shading object, and then it will reduce your solar load. And then down here is a contribution to my total cooling load of that window for both cooling and heating. And you can do this over and over again for all the different windows. South window, south, another south window, east facing window. And the windows are really what contribute most to your load, if you think about it. I mean, in this case, we have a lot of envelopes, but as you know, per square foot, windows provide, obviously, contribute a lot to your cooling load. So it's really important that you get your window information correct. All right, let's move on to skylight. So in this case, we only have one skylight. So skylight, obviously, is a window on a roof. So here we attach the ceiling. So what it's going to do, it's going to bring up a list of all of the ceilings that I defined under my envelope section. In this case, I only defined one. So I select that one. Then here's construction numbers for my skylight. Once again, single, double, triple pane. Actually, are there triple pane? Let's go down. Oh yeah, there are triple pane. There we go. Yeah, a lot of different skylights here. With different curbs and sashes, etc. Then based upon, oh yeah, and also curb construction here, metal, wood, R6 or other. And based upon the selections you make here, it will auto-fill in my U value for that skylight and also my SHGC value for the skylight. You can always override it if you want. Then here you enter the area. Suppose if you have multiple skylights, you can enter the area of one of them, and they're the same size. You just enter the quantity. Once again, it just performs the math, 8 times 2. Here's the total contribution to my cooling load, 1,300, and heating load, 650. And once again, you can add as many skylights as you want, and also copy from existing skylights if you happen to have a template. All right, so we've entered all of our parameters for our block load. So now let's look at some of the reports that can be generated. So to generate reports, you click this little pie chart icon here, and you can click it once and you can see a whole list of options here. Let's talk about system reports. So if I click that, you'll see it pops up a form that will display all of the inputs and outputs. Okay, so here are my inputs, here are my results. It's kind of like a overall summary report. If I swipe from right to left, here's what we call a checksum report. It kind of shows you rule of thumb values and different interesting information, CFM per ton, square foot per ton for cooling. Here are checksum values for heating. Here's my cooling load breakdown. We saw this on the screen, but this is actually in the report now. Our total breakdown, including percentages for cooling, for heating. Here's my room by room. I haven't shown you room by room yet. I will show you that in just a little bit. And then here's my pie chart with generalized breakdown and also for heating. And then here's what's called my AED curve, adequate excursion diversity curve. So this is a requirement of getting ACCA approved. And basically, it's actually a pretty cool thing. It actually, what it does is it shows you how your cooling load changes throughout the day, all the way from 8 a.m. to 8 p.m. And you can see in this case, you know, this house kind of peaks at around 1 p.m., which is pretty typical, you know, and then it starts, the load starts decreasing. But depending upon where your windows are, you know, it could peak in the morning if they're east facing, or it could peak in the late afternoon if it's more west facing. So really depending upon where the majority of your windows are, this curve will change. So, and this is a requirement, like I said, of being ACCA approved, and is included in the reports. So what you can do here is, I can't show this on my emulator because my emulator doesn't have email associated with it, but if you click your little envelope icon here, it will pop up your email client and allow you to email these reports as PDFs, and you can email them to anyone you want. This little icon here allows you to air print. So if you have an air print enabled printer, it will send these reports directly to the printer. All right, so I clicked done. Let me go back here and explain a couple more reports. Room reports, I'll show you after I show you the room by room, which we have about 15 minutes left. I'll show you that. This is a new feature, input reports. We were getting a lot of requests for this. People wanted to be able to print all of the inputs, everything that you've inputted. Well, you can do that now. I can select my project inputs. There they are. Once again, I can email them or air print them. Or I can actually go back, input reports, envelope reports. There's a list of all the envelopes I defined. I can print those. Window door, skylight, and room inputs. So it's a great way if you want to print all of your inputs. You can do that. Email HTML report. I can't show this once again because I don't have an email client on my emulator here, but it will actually email a spreadsheet of all of the results. And it's a CSV file, so you can open it in Microsoft Excel. All right, before I move on to room by room, I do want to explain a couple more of these icons here. The I button. The I button is kind of general settings for this app. I'll talk about this in a second up here, but if you suppose you're doing a job in French Quebec and you need to do metric units, you can always do metric, click SI. Down here is, some people get confused and think these are values actually apply to my project. No, these just apply to the max values on my slider control. So in this case, I'll show you floor area, the max value is 10,000. So if I go down here to my floor slider, you can see I can enter a max value of 10,000. Suppose I have a really large building or house that's over 10,000, I can always change this, up to 50,000. And all it does is it changes the max value. It does not actually change the value that I've entered for this project. Some people get a little bit confused on that. When in doubt, just don't change this information. And then down here, you can enter your company information, and this is printed on the reports. Over here is the help. You click it, it will display web help, and it basically instructs you on this entire program with visuals. So nice comprehensive help. All right. Are there any questions before I start talking about room by room? Okay. All right, room by room. So as I mentioned, room by room is optional. If you're just doing a block load and all you care about is your total, equipment size for your cooling and heating, then all you need to do is your block load. However, if you do want to get more granular, you want to calculate individual loads for each room, and also you want to size ductwork for each room because it will calculate airflows, then yes, you do need to do your room by room. Obviously, that'll add time you are, out there in the field, but it is important if you want to get more granular. So the room list, another thing I want to mention too, and a lot of people, we get a lot of calls on this. People are always asking, hey, how come the total of my room by room loads is not equal to my block load? Well, it's never going to be equal to your block load. If it is equal to your block load, it's a total coincidence. The reason your room by room will not be equal to your block load is a couple of reasons. One is, you may enter all your rooms, but you may not enter, say, your hallways and others. So this total square footage of all your rooms may not quite equal your total block load. So there's going to be a little differences there. The other difference is your rooms peak at different times during the day. For example, if you have a bedroom that's facing east and has a bunch of windows, that cooling load is going to peak in the morning. However, if you have a living room that's on the west side of your home with lots of windows, that cooling load is going to peak in the afternoon. So if you start adding summing of all those peaks, it's always going to be greater than your block load. Okay. So like I said, your room by room total cooling and heating load will almost never be equal to your block load. And if it's different like that, don't worry about it. It's supposed to be that way. Like I said, we get lots of calls asking us why, and I have to explain that, and that's the reason why. All right, so here we have our room by room list. Once again, click the plus button, add a new room, or copy from an existing room. So, like I said, the easiest way to use this program is create a template of some basic inputs that you're going to have to enter every single time for your projects. once you create that template, all you have to do is copy. And then you don't have to re-enter those input values. It saves so much time. It'll literally have the time that you're entering data. All right, so once again, I'm not going to go through all this whole list here just for the sake of time. We have about 9 minutes left. But let's talk about the office here. So I have an office. Then on the right here are my parameters for my office. And this is my main room parameters. So here I can enter the number of occupants. And if you remember under our block list, if I go back here, I had 5 total occupants into my home. Well, now I can start assigning those occupants to the individual rooms. And all it's going to do is it's going to add some internal gain to that room, mainly a sensible and latent load due to that occupant, because we're humans, we give off heat, right? And if you want to change the amount of heat we give off, both sensible and latent, click that I button that I talked about before, and you can see down here I have unit occupant sensible load of 230 and latent load of 200. And you may want to change this, especially, I don't know, if you're, say, sizing a small commercial building that, has a yoga studio or, an exercise studio or whatever. You may want to increase this because obviously people exercising give off more heat. All right, so what I really want to show you here, though, is our appliances. So you remember we defined a bunch of appliances here in our block load? Actually, just 2, but we could have assigned, 5 or 6. But now what you can start doing is assigning these individual appliances to the individual rooms. So if I click this caret icon here, it's going to give me that list of appliances I defined, and it's going to allow me to assign a quantity. So as you can see here, I defined 4 computers under my block load. I could say, hey, you know what? One of my computers is in my office. So I'm going to assign 1 here. And I have a television in my office because I like to watch the news during the day. So I have television. So now what? I click done, and it's going to add in for this room my total sensible load due to that television and due to that computer. So now I can start, what I'm doing here is I'm parsing out my appliances, spreading them throughout my rooms, and it's adding it in to my internal load here. So kind of a nice feature. All right, so we've defined some general properties for this office. Let's go to envelope. So, what we can do is now start adding individual envelope information for each of our rooms, in this case for our office. So, and also if you're ever confused, like, you're in the room by room section, you've selected an envelope, and you kind of forget, oh, wait, what room am I dealing with now? It will show it right here, okay? So it's showing my main project name, James Residence, and it's showing my office. So I'm working with my office now. So just as a reference. So now my office has a ceiling, it has a floor, it has a north wall and a west wall. So what I do here is I actually, and you can add, as many envelopes as you want for the office, copy from existing, same story as usual. So let's look at the west wall. So what I can do here is I can actually assign the envelopes that I defined under my block load to this room. So in this case, I'm assigning it the west wall. And then I enter the area that applies to this room. So if you remember, if we go back to block load and west wall, we had an area of around, let's say, 620 square feet, right? Now, if I go to my room by room, west wall, I can say of that 620 square feet, 220 applies to this room, to my office. And here it will show you how much is left. Okay, and I've obviously spread this west wall over a couple of rooms. Thing is, though, if you enter a value that's greater than what you enter in your block load, it won't stop you from doing that. You can indeed do that if you want. But this was kind of just a reference. So this is a nice little breakdown here of my cooling and heating load for this specific room only. So it shows you 5,800 BTU of cooling, 10,000 BTU per hour of heating. And here's my AED curve. You remember what I talked about before. And if it's blank here, just click the little calculator icon. It will calculate it. So the AED curve, this applies only to this room. Okay. As you can see, it's peaking in the late afternoon. So that means that our west-facing wall has some windows on it. So it's more peaking in the west. And as you can see, it's a lot different than the AD curve for our entire home, which is here. So it's really interesting to see this. For my individual rooms, I can also display AD curves and see when the loads will peak. All right, we only have a couple minutes left, so I want to get through this. Windows, same thing. You can add new windows, copy from existing. You select from this window list, which you defined under your block load, and then you enter the area of the windows that apply to this room, to my office. Same thing with skylight. In this case, I don't have a skylight in my office, so there's nothing there. All right, so I can do this for each room. And after I've done it, then you can go to the reports, click room reports, say I'll select my office. Here is my office report. Here's the pie chart for cooling, pie chart for heating. Here's my AD curve. You can print, email those as PDFs, print them, and do it for each office. And also, if you remember, under my system reports, I had kind of a comprehensive room list report here. Right here. So this lists all my rooms, cooling, heating loads, airflows, and totals. All right. So that's the room by room mode. One additional thing I do want to show you, this is new that we've added in the past 6 months, and this is what we call our ResLoad-J Cloud. And what you can do is you can actually save your projects in the cloud and download them to other devices. And the way you do that is if you click the I button, and in this case, I've already logged in, but it will say login, and you create a login and password. It will send you an email to confirm it. And once you do that, you can click this sync button here, and it will synchronize those projects to a cloud database. And I'm going to show you the web interface in 1 second. And then what you could do is, as an administrator, you can assign these projects to other users within your company, so you can share projects within your company. It's kind of a nice feature. So it comes with, you can synchronize 2 for free, and then if you want to go beyond 2 projects, you have to start paying a monthly fee for that. But that's optional, not required, the ResLoad-J Cloud, but it's a nice feature if you do want to share your projects with others. So I'll show you real quickly the web interface. Bear with me while I change my share settings here. Okay, so you should all see the web interface now. So this is a Carmel Equip Locator. So it's actually accessible from, if you go to carmelsoft.com, click sign in for Carmel Equip Locator. I'm going to log in as myself here. And then if I go to ResLoad-J project list, you'll see those 2 projects which were just up top there. They're now in this web interface, and what you can do here is you can assign these projects to other users within your organization. And I'm not going to go through all this since our time is almost up, but we have online help for how this is used. And if you do have more information on, if you're interested in using the ResLoad-J Cloud, feel free to email me, and I can, give you more information on it. So, are there any questions before I wrap up this training webinar? Remember to unmute if you do have a question. Okay, I take that as there are no questions. If you do happen to have, think of any questions after this call, feel free to email me. My email is sroth, S-R-O-T-H, @carmelsoft, same as our website, .com. So sroth @carmelsoft.com. And like I said, I'm going to be posting a recording of this video on YouTube, and I'll include a link to it in an e-newsletter we send out that you should be receiving. So if there are no final questions, I'm going to end this webinar. I really appreciate all of you attending this, and best of luck in using the ResLoad-J app.